Section 11.7. Our objective today is I can use Pascal's triangle to expand out a binomial raised to a power. So remember that a binomial is something with two terms, and we've done extensive multiplying out of binomials, and so that is called binomial expansion. So if I wanted to do a plus b to the 0 power, well, anything to the 0 power is 1, so that just would multiply out to 1. Then a plus b to the 1 power is just 1a plus 1b. Whoops. Okay. Then if I did 1 plus or a plus b to the 2nd power, that really means a plus b times a plus b. And if we FOILed that out, we would get 1a squared plus 2ab plus 1b squared. And if we continue doing that, did a plus b cubed, which means a plus b times a plus b plus a plus b, we would get 1a cubed plus 3a squared b plus 3ab squared plus 1b. Actually, there should be a 1 in front here. It should be a 1b. Okay. Then if we did a plus b to the 4th power, we would get 1a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1b to the 4th. And then if we did a plus b to the 5th power, we would get 1a to the 5th plus 5a to the 4th b plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the 4th plus 1b to the 5th. Right? Now you should notice here that there's several patterns going on. Okay? If you notice, starting at the 3rd row, okay, then, well, actually, each of the outer rows, or the outer ones, is 1, both this way and this way, okay? And starting at row 3, if I take these two, add them together, it gives me this one. Then at row 3, it starts with a 1, but then if I take this plus this, it gives me this 3. Then this plus this gives me this 3, and then it ends in a 1. Row 4 starts with a 1, then if I add these two together, it gives me this 4. Add these two together, it gives me this 6. Add these two together, gives me this 4, and it ends with a 1. Okay? And same thing with row 5. Starts with a 1, then add those two together, whoops, those two, gives me a 5. Add these two together, gives me the 10. Those two together gives me a 10 again. These two together gives me a 5, and then it ends with a 1. Okay? Also, notice that for each row, there's always one more term than the power. This one has a power of 1, but I have 2 terms. This one has a power of 2, but I have 3 terms. 1a squared, 2ab, and 1b squared. This one has a power of 3, but I have 4 terms. This one has a power of 4, but I have 5 terms. Okay? So that's another pattern that you should notice. Also, notice that the even powers have an odd number of terms. Okay? The other thing that you should notice is the powers. So notice that this matches this 4, and this is 3, and this is a 1, so those add up to 4. 2 plus 2 add up to 4. 1 plus 3, add up to 4, and that's a 4. In row 5, starts with a 5 squared, then 4 and 1 add up to 5. 3 and 2 add up to 5. 2 and 3 add up to 5. 1 and 4 add up to 5. So notice that for each term, the powers must add up to the power that you're raising it to. Right. Now, these green numbers that I marked out, those numbers form what we call Pascal's triangle. And Pascal's triangle gives us the coefficient of each term in the binomial expansion. When we multiply these out, that's called a binomial expansion. Okay? So if we take just the coefficients, we get Pascal's triangle. So Pascal's triangle, row 0, the first row is called row 0 because it's to the 0 power, gives us just a 1. Row 1 has a 1 and a 1. Row 2, because that is the squared 1, we have 1, 2, 1. Row 3, we have 1, 3, 3, 1. Row 4, 1, 4, 6, 4, 1. Row 5, 1, 5, 10, 10, 5, and 1. Row 6, we have these. And we can construct row 7 by remembering that the pattern is the outside number is always a 1. Then the next number is the 2 above added together. Then the next 2 added together. Then the next 2 added together. Then the next 2 added together. And it always ends in a 1. Okay? So these represent the coefficients if I took a plus b to the 7th power. Those represent the coefficients. So I could construct what this would come out to by using the patterns. So we know it would be 1 times a to the 7th plus 7 times a to the 6th, b to the 1, plus 21 a to the 5th, b to the 2nd. So notice that the a is the power on the a is decreasing by 1, and the power on the b is increasing by 1. So this one would have been b to the 0 here. Okay, so then the next one would be 35 a to the 4th, b cubed. Then the next one would be 35 a to the 3rd, b to the 4th. And I ran out of room here, so I'm going to come down here. The next one would be 21 a to the 2nd, b to the 5th, plus 7 a to the 1, b to the 6th, plus 1 a to the 0, b to the 7th. Okay? So if I actually multiplied this out 7 times, that's exactly what I would get. Right, so we can use that to expand binomials. So example. Expand and simplify each expression. Okay, so let's say I want to do a minus b to the 4th power. Okay, well, that means I'm using row 4 of Pascal's triangle. Row 4 of Pascal's triangle has a 1, a 4, a 6, a 4, and a 1. Okay, so then it would be 1 times a to the 0, and this is a negative b, so it's negative, I'm sorry, that should be a to the 4th and it would be negative b to the 0, plus the next number is a 4, a to the third, negative b to the 1, plus the next number is a 6, a to the second, negative b to the second. Again, notice that the exponents always add up to 4 in this case, plus 4, a to the 1, because we decreased by 1, negative b to the third, because we increased by 1, plus 1, a to the 0, oops, should be negative b to the fourth. Now we just go back and simplify. This is just 1, so it's a to the fourth, plus, or actually, this b to the negative 1, or negative b to the 1, I should say, is negative b. So it's going to be minus 4a cubed b. This negative b squared makes it positive, so the next one's going to be a plus. So it's going to be 6a squared b squared. This one, it's raised to an odd power, so it's going to be minus 4ab cubed. And then this is even, so it's going to be plus. And so we get 1b to the fourth. Okay, notice then that when the second term is negative, notice that your signs alternate. This is plus, minus, plus, minus, plus. So when this is a negative, your signs are going to alternate. Okay, example 2. So this is example 1, example 2. Right, I want to expand out x minus 3 to the third. Okay, so that is row 3 of Pascal's triangle. So we go up to row 3, and in row 3 we have 1, 3, 3, and 1. Okay, then this is your a term, and this is your b term. Okay, so it's going to be 1, it's going to be 1, our a term to the third power, our b term to the 0 power, plus 3, our a term to 1 power less, our b term to 1 power more, plus our a term to 1 power less, our b term to 1 power more, plus our a term to 1 power less, and our b term to 1 power more. Now we go back and simplify. This negative 3 to the 0 is just 1. So this first term simplifies to just x cubed. Then the next one's going to be a minus because we have a minus b term. And then we would take this 3 and multiply it times this, so it's 9x squared. Then it's going to be plus, then we square this, which gives us 9. 9 times 3 is 27, so 27x to the 1, plus, oops, this should be a minus because we're alternating, minus, this is just 1, and negative 3 to the 27, or negative 3 to the third is 27. Okay? So if I took this and multiplied it out, this is what I would get. That would be my final answer. Okay? All right. Let's look at example 3. So if I wanted to find the first 3 terms of the expansion, oops, of, and I want to do 2x minus y to the 6th. Okay, so in this case, this is my A term, this is my B term. Okay, and we're in row 6 of Pascal's triangle. So we go back up to Pascal's triangle, and row 6 is 1, 6, 15, 20, 15, 6, 1. Also notice that this is symmetric. It goes up to 20 and then comes back down with the exact same numbers. Okay? So I only want the first 3 terms. So the first term is going to be our 1 times our A to the power, and our B to the 0, plus our coefficient times our A term to 1 power less, our B term to 1 power more, plus our next coefficient times our A term to 1 power less, our B term to 1 power more. Okay, so now I have 3 terms. Here's the first term, here's the second term, and here's the third term. Now I just need to simplify those. Okay, so this is just 1, and this is, I have to distribute this in, so this is 2 to the 6th, x to the 6th. Then it's minus 6 times, distribute this in, 2 to the 5th, x to the 5th, plus, distribute this in, 15 times 2 to the 4th, x, and y squared, because this is going to give us y squared. It shouldn't be a negative 2, it's just a 2. Okay, then continue simplifying. 2 to the 6th is 64, so we have 64 x to the 6th. 2 to the 5th is 32 times 6 is 192. X to the 5th, whoops, I forgot my y here. This should be a y to the 1. And I knew I'd made a mistake because my exponents have to add up to the power. So it should be y to the 1, and then it's going to be plus, and then it's going to be 2 to the 4th, 16 times 15 is 240 x to the 4th, y to the 2nd. Okay, and because I distributed that in, I forgot to write the 4 there. Okay, so the first 3 terms of this expansion, if I multiplied that out, wrote it out 6 times and multiplied it all out, the first 3 terms would be these right here. Okay, and one final example. The first 3 terms of x plus y to the 17th are x to the 17th plus 17 x to the 16y plus 136 x to the 15y squared. Write the last 3 terms. Okay? Well, remember it's symmetric. And remember that the x's are decreasing, the y's are increasing. So my last y is going to be to the 17th power. Okay? Then the y before that is going to be y to the 16th, and it's going to be x to the 1. because the exponents have to add up to 17. And since it's symmetric, then the next one would be, the coefficient would be 17. Plus, then my next y would be 15 and x to the second. And then the coefficient would be 136. Okay? And so notice that the powers here are exactly the opposite as the powers here. Notice that the powers here are exactly the opposite as the powers here. Okay? And so the coefficients match up, right?